Let's go ahead and talk about valence shell electron pair repulsion theory. And in valence shell electron pair repulsion theory, what this does is it allows us to predict the molecular geometry of different compounds. And what the molecular geometry is, it's the shape of a molecule. It's the shape that the molecule makes. And remember that a molecule is a covalent compound, which again is a nonmetal plus a nonmetal. I think I've said that probably 10 times within this unit. So the first thing that we want to do is identify the central atom. And so we're going to go ahead and think about these different molecular geometries. And the first thing we want to do is think about the central atom. Now the central atom is going to be the one that's the least electronegative atom, but it's also going to be the one that is the fewest, that has the fewest number of atoms. So you just look for the one with the fewest number of atoms. So in this situation, you've got boron is the central atom. Oxygen is the central atom here. And this last one, it's carbon, because again, all those have the fewest number of atoms. There's only one boron here, one oxygen, one carbon. Now we want to talk about lone pairs. Now lone pairs, they are pairs of unbonded electrons. They do not participate in a bond. However, they do have an effect on the shape of a molecule. So let's go ahead and draw the Lewis structure here. In this situation, there's 0 lone pairs. We have 3 single electrons, but 0 pairs. In this situation, if you take a look, notice how we end up with 3, 1, 2, 3 pairs of electrons. Now, if we take a look at carbon, carbon has 4 valence electrons. And notice how there's 0 lone pairs. Oxygen has 6 valence electrons, and I'm going to go ahead and do that again. It goes 1, 2, 3, 4, and then we have 2 pairs. And so understanding how many lone pairs a particular atom has is important for understanding the geometry that the molecule will make, because the lone pairs actually affect the geometry. Now, here are the different shapes that are possible for molecules. And so the first thing you want to ask yourself is how many number of elements are bonded to the central atom. I'm going to save this for last here. But let's go ahead and take a look at this central atom here. So how many elements are bonded to the central atom? 2. You can see that this has 2 elements bonded to the central atom. This one has 2 elements bonded to the central atom. And all you need to do is answer this question. Does it have lone pairs? If no, then it's going to make this shape right here. Now, this shape happens to be called linear because look, it makes a straight line. Now, if the central atom does have lone pairs, say yes, and notice the shape that this makes. It makes a bent shape. Now, the reason why it makes a bent shape is because inside of these bonds here are electrons, and this lone pair of electrons actually repels these bonded pairs. All right, let's go ahead and go on to the next one. These have 3 atoms bonded to them. If the central atom does not have lone pairs, then it's going to be called trigonal planar. And the reason why it's called trigonal planar is because it's flat. But if the central atom does have lone pairs, kind of like this, it's still going to be trigonal. And the way we remember that, it's got 3 atoms, so we can remember trigonal. But it's trigonal pyramidal. And the reason why it's trigonal pyramidal is because the lone pair repels the bonded pairs and pushes them down to make a sort of pyramid, a 3-sided pyramid, similar to what happened with the bent shape. And then the last one, if it has 4 atoms on the central atom, we're going to call that, and then this is it's the only situation you'll come across. We're going to call this tetrahedral. Again, tetra means 4. So it's called a tetrahedral. Now this one here, there is no central atom, so we put not applicable. So if there's no central atom, it doesn't matter if there's lone pairs or not. If there are just 2 atoms bonded together, this is also called linear. All right, so let's go ahead and do some practice problems. If you take a look, here's silicon. So how many atoms are bonded to the central atom? Take a look, there's 4. Are there lone pairs on silicon? Well, if we draw the Lewis structure, it has 4 valence electrons here. There are no lone pairs on silicon. And so if we look at our notes here, 4 with no lone pairs is tetrahedral. It's very easy. Tetrahedral. Now the Lewis structure, again, there's 4 valence electrons, and then we have 4 of these guys all around. I'm running out of space here. Actually, I'm going to write a little bit smaller. So 4 valence electrons, and then we have 4 of these. And then we got lone pairs on these guys as well. A lot of dots, and there's a bond here, 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 and here, and that would make a tetrahedral shape. All right, carbon is the central atom, and if you draw the Lewis structure for carbon, there are no lone pairs. So there's no lone pairs. Now there's 2 sulfurs attached to that carbon, and so what has 2 atoms and no lone pairs? 2 atoms, no lone pairs, linear, easy peasy. And this one, sulfur, carbon makes 4 bonds, sulfur makes 2 bonds, and the reason why we know that is because if you take a look at the Lewis structure, 4 single electrons. Now sulfur has 6 valence electrons, and so it looks like this. Notice how it has 2 single electrons. So each sulfur makes 2 bonds, and the carbon makes 4 bonds. And so if you do a double bond between each one of these, notice how this makes 2 bonds, 2 bonds, 4 bonds. And so that works out. And then sulfur has its lone pairs. And again, when we're looking at the shape, though, we want to look at, does the central atom have lone pairs or not? That's what matters, and carbon does not. All right, next one, phosphorus. If you take a look, phosphorus has 5 valence electrons. And so notice how there's 3 single electrons and there's 1 lone pair. And so the question is, how many bonds, or how many atoms are bonded to the central atom? 3. Does the central atom have lone pairs? Yes. So what's 3 with lone pairs? Trigonal pyramidal. All right, let's go ahead and draw the Lewis structure of this. All right, so we have phosphorus, and we've got our 5 valence electrons. Yes. All right, so there we go. So now we've got our Lewis structure there. We've got, if you take a look, there's 3 bonds on the phosphorus. Each astatine has 1 bond, and that's it. And that's all there is to it. So really the big thing is making sure that you're able to count the number of atoms bonded to the central atom. Very easy. And then determining if there's a lone pair or not. And then you can just look at the chart here to determine the shape. And that's it. Come to class with questions. Have a great day.